Hello and welcome back. And today we are going to be, or this time, this video, we're going to be talking about right endpoint sum, which is a type of Riemann sum. And again, we're doing right because we're doing the right endpoint of each rectangle to find the length. Now, if you were just watching our other video with the left, you'll see all this beautiful work. If you haven't watched the left one, I would watch that. Some things are not going to change. We're still finding the area under the curve of y equals x cubed. We are still, if you look back over here, having 4 subintervals. So n is equal to 4 again with the subintervals. And we're going to still have our width, which is equal to delta x, which is not going to change that formula, b minus a over n. In this case, we're still starting at 0 to 2. So our b and our a, this was our a, if this was our b, if you remember, the endpoints of our interval, still going to be 2 minus 0 over 4, 1/2, and I believe that that's what it was over here, 0.5, whoops, I'll stay consistent with some decimals, I apologize. So 0.5, now we'll be staying on this right endpoint sum page, not flipping back and forth. Okay, so we have to find x sub I again. We have our width, we need our length, which is going to be represented by these points. So our length is f of x sub I. We need a formula for x sub I when we do right endpoint sums. Now some of you may have guessed already what it may be. Remember, we have to do this. Our last one was minus 1 because it was shifted over here, 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 here. But this time it's not shifted over, it's right here. So in order to get this, the formula is actually just a plus I times delta x. And if you don't believe me, let's look for this particular case. Our particular case here for this example, 0 is a, I times our 0.5, our delta x. If I plug in for our first rectangle 1, this is our first rectangle, 1. If I plug 1 in there, guess what I get? 0.5. If I plug in 2 for our second rectangle, guess what I get? 2 times 0.5 plus 0, I get 1. 3, I get 1.5. 4, I get 2 when I plug it into there. So that is our x sub I for this case. Our f of x sub I, then, remember we're going to plug this, which is simplified, to simply I times 0.5, into my function x cubed. So f of x sub I is going to be I times 0.5 cubed. Alright? That could be even written simpler as 0.5 I. Okay? So that's f of x sub I. Alrighty? So now we're going to do our summation again. I equal 1 to the number of rectangles, which we're just going to say n, which is f of x sub I times delta x. For this particular case, our n will change depending on the situation. We have I equals 1. F of x sub I is given by this, so it's going to be 0.5 I cubed times delta x, which is 0.5. Some of you may ask, why do you have delta x here and you have it in here as part of x sub I? This just generates each of my x values. That is not being multiplied by the width for the rectangle to find the area. This delta x is allowing us to kind of shift down the line to find the x value for each one of our representative rectangles. Now, if I can do just what I did with the last situation, and I can go, we plug in 1, 2, 3, 4 in here. So 0.51 cubed plus, I did it again, I'm forgetting. Now remember, this 0.5 is constant, and it gets multiplied to each one of the rectangles, so I can just put it outside here. Put it outside. I don't know if you guys have ever watched, and ladies have ever watched Bob Ross, The Joy of Painting. I feel like Bob Ross when I do these videos. I feel like little old Bob. May he rest in peace. Pretty little parentheses. Doesn't mean anything to you if you haven't seen Bob Ross in action. Pretty little parentheses. Happy little exponent. So if we do this computation, this calculation, and we multiply this by this and cube it, and this by this and cube it, and this by this and cube it, and this, and we add it all up and multiply point, you'll get the sum of 6.25. Wow. 6.25. You may already know that this is an upper sum. Now the question I need to ask you is the right endpoint sum always the upper sum? And is the left endpoint sum always the lower sum? So think about that question. Think about that question and see if you can answer it. And I know I posed it in class and some people already had like kind of a thought about it. But here you go. All right. So this video was about right endpoint sums. This was for this particular function, y equals x cubed, for 4 subintervals. All right. So every problem may see some little different in class when you have to kind of do this on your own. You're going to have a different function. So keep that in mind. Alright, so I hope you enjoyed this video. Johnstone, out.